In this example, we are going to solve a comprehensive problem that covers several important concepts in discrete-time LTI systems. By working through this example, you will gain a deeper understanding of impulse response, causality, stability, frequency response, and the magnitude and phase responses of an LTI system. Let's solve the problem step by step. Part 1. Finding the impulse response. The problem first provides the relationship between the input and output of an LTI system and asks us to determine its impulse response. Let's begin by recalling an important facts. For every LTI system, the output is equal to the convolution of the input signal with the impulse response. We also recall two useful convolution properties. The convolution of any signal with a unit impulse is simply the signal itself. Likewise, the convolution of any signal with a shifted unit impulse produces the same signal shifted by the same amount. Using these properties, we can rewrite the output equation. We replace xn with the convolution of xn and delta n. Similarly, xn minus 1 becomes the convolution of xn with delta n minus 1. Finally, xn minus 2 becomes the convolution of xn with delta n minus 2. Now we factor out xn from every terms. The remaining expression is delta n plus 2 delta n minus 1 plus delta n minus 2. Comparing this result with the standard convolution equation, we immediately identify the impulse response. Therefore, Hn equals delta n plus 2 delta n minus 1 plus delta n minus 2. If we sketch this impulse response, we obtain an amplitude of 1 at n equals 0, an amplitude of 2 at n equals 1, and an amplitude of 1 at n equals 2. This completes the first part of the problem. Part 2 is the system causal. Next, we are asked whether the system is causal. For an LTI system, causality requires the impulse response to be 0 for all values of n less than 0. Looking at Hn, we can clearly see that all samples for negative values of n are 0. Therefore, the system is causal. Part 3. Is the system stable? Now let's determine whether the system is stable. An LTI system is stable if the summation of the absolute value of the impulse response over all values of n is finite. In this case, the absolute value are 1, 2, and 1. Their sum is 4, which is a finite number. Therefore, the system is stable. Part 4. Finding the frequency response. Next, we are asked to determine the frequency response of the system. Let's first recall two important Fourier transform properties. The Fourier transform of the unit impulse is equal to 1. Also, the Fourier transform of a shifted signal introduces an exponential factor. Using these properties, we take the Fourier transform of each impulse in the impulse response. The transform of delta n is 1. The transform of 2 delta n minus 1 becomes 2 e to the power of minus j omega. The transform of delta n minus 2 becomes e to the power of minus j2 omega. Adding these terms together gives the frequency response. Now we factor out 2 times e to the power minus j omega. After simplification, the remaining expression becomes 1 plus cosine omega. Therefore, the frequency response is 2 1 plus cosine omega multiplied by e to the power of minus j omega. Part 5. Magnitude and phase responses. Finally, we are asked to determine the magnitude response and the phase response. Recall that the frequency response can always be written as the magnitude response multiplied by e to the power j times the phase response. Comparing this expression with the frequency response we obtain, we immediately identify the magnitude and phase. Magnitude response is 2 times 1 plus cosine omega. The phase response is simply negative omega. Sketching the magnitude response. Let's now sketch the magnitude response. We begin with the graph of cosine omega. Adding 1 shifts the entire curve upward by 1 unit. As a result, the minimum values becomes 0 while the maximum values becomes 2. Finally, multiplying the entire expression by 2 doubles the amplitude. Therefore, the maximum values becomes 4. This is the magnitude response of the system. Sketching the phase response. The phase response is much simpler. Since it is equal to negative omega, its graph is simply a straight line with a slope of -1. This example covered several important concepts in signal and systems. We learned how to determine the impulse response, verify causality and stability, compute the frequency response, and finally obtain both the magnitude and phase responses. If you found this tutorial helpful, please like the video, subscribe to the channel, and leave a comment below. If you have any question, feel free to contact me using the email address provided in the video description. Thank you for watching, and I will see you in the next tutorial.